What is up, everybody? How's it going? So, today we're going to be talking about setting up our parser. It's going to be part two. And just in case if some of you guys ever noticed, I did cancel or I'm no longer going to be showing my intro because of copyright reasons, obviously. So unfortunately, my intros aren't going to be as nice as they were before, but that's just something that I had to do moving forward. If I do find a better song that kind of matches with the video I edited, because I worked really hard on that to make that, then I'll probably add it back in. But for the time being, I'm just going to start off without the intro. Also, I wanted to mention really quick, I wanted to apologize about the absolutely terrible titles of my videos. I know they're not exactly explaining truly what I'm talking about in the video. Like, for instance, this one's going to be setting up the parser part 2, and that's what it's about, but I'm going over a lot of other things under that video, so it's a bit challenging because I have tons of other videos that I'm having to rehash. So once we get to a point where we're talking about the compiler, like right now, I'm going to be showing you guys all the code in here. But once we get done with the front end and we start working on the back end part of our compiler, the titles of my videos are going to be a little bit more descriptive in terms of what we're talking about, and it's mainly just going to focus on that. And I'll also be able to make much smaller videos because I can start to focus on a lot more nuanced details and split things up a lot easier. But yeah, with that said, let's just jump right back into it. So I'm going to go back up here and we're going to go back to our main. So if you guys remember, 2 episodes ago, I think it was, I talked to you guys about how to set up your initial entry point. So the bootstrap is what effectively gets called. So this is the initial entry point of our compiler. And if I go way down here, I have an actual main.c++, and this is what is our main file. So when our program actually starts, I have both code to make the compiler and code to not make the compiler. And basically what this represents is I have in my CMake list, I have define statements so I can say whether or not I want to build the compiler, or I can comment this out. And if I'm not building the compiler, then it will just build the virtual machine. So that's kind of how that works, and that's why I have that. But yeah, so we're going to go back into our bootstrap. So once you kind of have like the initial point where when the user starts up your application and it validates all of the options and source files and everything that the user passed to it. And once we get through all of that, we need to start to set up the actual program. So we need to actually get ready to compile everything. So in here, I have a compile. So I'm basically just going to pass in a list of files. So once I know everything that I'm processing, this is going to be all of the total files that our compiler is going to come across. The first thing you're going to want to do is you're going to want to create an array of parsers. You're going to want to create a current parser pointer. You also want to create a current tokenizer that you're pointing to represent the current file that's being tokenized. You also want to create a file buffer. Now, this is a actual library that I created. It's pretty straightforward. It basically just uses a C++ file. So if you guys want, you can just go here. So I'm going to collapse this. If you go to my libutil, you can see I have a file, header file and a file, C++ file. You could just copy this code. It's really nice. So that's what that represents. But I'm going to go back. After that, we want to create our errors. So we want to have the errors that the user sees and then our total unfiltered errors. How many files succeeded, how many files failed, and how many files just panicked out. And then, of course, we want to have our for loop we want to just go through all of our files. Um, and in there, we want to create a string, and we want to get the first file, and we want to call our buffer begin. And what that does is that sets up our file buffer to get ready to actually access all of the data in this file. So what we're going to do is we're just going to read the entire file. So again, if you guys remember in my last episode, I was talking about what if you process a 1 GB file. That is a bit ridiculous. So at this point, I'm just basically going to always pull in the entire data of the file and just kind of go from there. So I check to see if the buffer is empty. So if our file is empty or it has nothing in it, we want to just complain to the user and say, hey, the file is empty. If you remember, that just basically shuts down the actual compiler. Let's go back. After that, if our file is good, then we actually want to process it. So this is pretty easy. It's not that difficult the way I set it up. So if you guys remember, I have this debug mode flag, and what this is it's just an Easter egg flag to basically see what's going on. So you can see here, I'm saying I'm tokenizing this file. So this is very important. You guys definitely, I would recommend adding this to your compiler as you're building it. Eventually, I'm going to delete this, and it's going to be very easy because all I'm going to have to do is just go here, click Find Usages, and look for all the usages in my code that is using this Boolean flag and it's checking it. And wherever that is, I'm just going to find it and delete the code once the compiler is actually done. But for the purposes of developing the compiler, this is really good because if you have an error, then it's really easy to track. Next, we want to create our tokenizer. So we create our new tokenizer here. We just pass in the entire buffer, um, and we pass in the name of the file, where is that at? Oh, okay, so it's up here. So we pass in the name of the file, and then we also pass in the data or the contents of that file contains. And then after that, we want to check to see if our cursor or our current tokenizer has any errors. So we want to get the error management system of that tokenizer. And each tokenizer, by the way, should have its own error management system. We don't want to have a global error management system for all of our tokenizers, our parsers, because if that's the case, it's going to be very difficult to track what broke and why. For instance, let's say the tokenizer of our first file broke, but the tokenizer of our second file didn't break. Well, then how do we know whether or not to parse that? Because we are always going to think we always have errors. So you want to separate out your error management system for each individual tokenizer and parser. So that way you can respond to it accordingly. So you know specifically this file broke at this point in the compilation process. Only once we get to the actual compilation process is when you're going to want to actually have just a single error management system. But for the purposes of tokenizing and parsing, you want to individualize it. So if we determine that we have any errors, then we want to get the errors and we just want to print them out. So you guys have seen this code before. It just checks some flags here and it just prints out the appropriate errors that it needs to print. After that, we want to tally up or add that to our total errors tally. And so we want to get the total error count. We want to also get the total unfiltered error count. So this is what the user sees. This is what is actually found. And then we want to add this to our failed count. So we want to say, this file failed because it didn't go through. Now, if there are no errors, then great, we're ready to actually parse it. So once that's ready, then we check our debug flag, we say parsing, and then we have our parser here. So we want to create a new parser, and we want to pass in our tokenizer here. So I actually just moved some code here. So after we create our parser, we want to check to see if our parser has any errors. If it does, then we want to basically print out the errors. And we want to basically just do the same thing we did up here. So we want to tally up the total errors. We want to say this one failed. And if it panicked, then we want to say panic is equal to 1, and we want to just go to n. So this is important, right? If we if anything panics in our code, right? So if anything flips out like this, that means that we have too many errors that we came across that something's obviously not right. So if our tokenizer panics, or if our compiler panics, that means that we just need to cease all compilation completely and we don't need to move forward because I don't know, maybe they're trying to compile a Java file and this compiler is built for compiling chart files or something like that. So we just want to go to the end, and that basically just frees up our buffer, frees up our tokenizer, frees up our data, and then it said detecting more than, whatever our error limit is, and then it says quitting. So if you remember, the user can actually change this so they can set it to as low as 10 errors if they choose to, or as high as 100,000. So that's why I have that panic check there. Otherwise, if it's good, then we want to add this current parser to our total parsers list because we want our compiler to only compile parsers that are working 100% of the time. After that, so we already saw this code. This is the end code where once we finish processing every single parser. So after every single file is processed, we want to, and it actually has data in it, we want to clear the tokenizer and we want to clear our buffer, but we do not want to clear our parser. So here I'm actually going to add some code here because I just realized. So if our current parser panicked, we want to delete it because we still have to check the instance to make sure it's good. Then we delete it here. Otherwise, if it didn't panic, we delete it here because obviously it had errors and we just print it out. So there's that. So down here, you can kind of see, this is also, by the way, outside of the for loop. So once we've parsed and tokenized all of our files, then we want to do some basic checks. So this is what determines whether or not we're actually going to compile. So what we say is if nothing panicked and we have absolutely no errors and we have absolutely no unfiltered errors. Now here's why I have both of these. I had a bug in my compiler. I think it's fixed, but I had a bug in my compiler where you could have 0 errors, but you could have maybe like 1 unfiltered error because my error management system is a bit overprotective when it comes to figuring out which errors are supposed to be there and which errors aren't supposed to be there. So I had some weird bugs with that. So I'm just making sure that we absolutely have no errors. And if that's the case, well, then great, we're ready to compile. So that's kind of why I have both what the user sees and what the error management also saw. So after that, we of course check our debug flag and we say performing syntax analysis on project files and we start our compiler. Now, obviously, we're not talking about the compiler today. We're talking about setting up our parser, but this is the code that runs once we're ready to compile and that sets up everything here. So after that, we of course do our vanilla things that we've done up here for our parser and our tokenizer. We just, add up our tallies. Um, and we want to make sure if we have absolutely no errors, then we want to check to see if we have the compile flag. So if the compile flag is set to true, that means we only want to compile the file. So in order for us to generate the code, the compile flag has to be set to false. And if that's the case, we call our compiler.generate and then we clean up our compiler. Now, of course, obviously, if everything wasn't perfect, so if something panicked or we had some errors, then all we want to do is we just want to delete or free up all of our parsers, and then we want to print out the results. So this is important. I really like this because it basically just shows what happened in our compilation process. What we're checking here is we want to say, do we have aggressive errors set to true? And if we do, then we want to tell the user, here's every single bit of error that I found, every single error that the compiler found. Otherwise, we want to print out the filtered set of errors. So again, if you have like maybe 100 errors, the user may only see 30 of them, maybe 40 at max. But yeah, that's what that is. And then of course we want to say succeeded. So we want to say how many files succeeded, how many files failed, and here is the total amount of files that we have. And that's it. And std flush is a way to just immediately print out the value of cout. So whatever you sent to the standard out, you can just immediately do that. This is used in a lot of places in my code when I want to, during debugging, immediately print something after the statement is executed. So it's really nice, just in case if you guys didn't know what that is. But yeah, so that is the entire compile code. So I want to, in the spirit of creating short videos, I am going to stop it here and I will have another video out on Wednesday. And what that video is going to be is that's strictly going to be just talking about our parser. So I'm going to go into grave detail on how to actually set up our parser. I'm going to talk about all the fields that we need, what they mean, all the functions that we're going to need for our parser, and anything else you guys are going to need to know to set it up. So that's it for today, guys. As per usual, I'm going to do my exit portion of the video. If you guys would love to support the channel, definitely watch, star, and fork the project. That gives this project a lot more visibility and lets other developers know the language exists. Also, if you guys want to stay up to date with the development of the actual project, definitely check out Master and Remastered. Any other branches are null and void. And if you want to be more up to date with the language in real time, you can definitely check out the Remastered branch. This branch encompasses live development on all the things that I'm doing in the programming language, and it is updated on almost a daily basis. Also, if you would like to get more details about what I plan to add to the language or maybe some stuff that I'm working on, definitely check out the roadmap file. That is going to contain all the things that I've either completed, which represents stuff with checkboxes, or things that I'm still working on, which represents things without checkboxes on them. Also, if you want to even have a more detailed approach in terms of past versions and see kind of what I've already added to the language, what I've done in the past, or bugs that I've fixed, definitely check out the changes file, and that's what that will contain there. So, hope you guys enjoyed the video. Definitely like, comment, and subscribe if you guys like what you saw and you want to see more. And until next time, I'll see you guys later.